In this tutorial, we will be discussing how to name acids. Acids are molecular compounds that form ions when dissolved in water. They are composed of hydrogen, usually written first in their formula, and one or more nonmetals written second. We can categorize acids into two groups: binary acids containing hydrogen and a nonmetal coming right off the periodic table, or oxyacids, those containing hydrogen, a nonmetal, and oxygen as well, and these are going to be the polyatomic ions. So to break it down, here are the acids. Binary is one where it comes right off the periodic table, and it'll be bonded with a nonmetal. Whereas the oxyacids are from polyatomic ions. And there are different ways to name each of these categories. So let's focus on the binary first. Remember, those are the ones from the periodic table. It's going to start with hydro, symbolizing the hydrogen, then the base of the name of the nonmetal. So when we talk about the base of the name, we're referring to the first syllabus typically, just like we did when we were naming ionic compounds. But instead of putting "ide" at the end, we're putting "ic" along with the word acid. So for instance, here it's coming right off the periodic table. We have chlorine, so it becomes chloric acid. Hydro for that hydrogen, so hydrochloric acid. You know it's coming right off the periodic table because of the fact that there's only two capital letters here, meaning that there's only two elements. One of those elements is already going to be hydrogen, so there's only one other element there. So that's why it's binary, because there's only two elements. So bromine becomes bromic, then hydrogen, so hydrobromic acid. HCl gas refers to hydrochloride molecules in a gas phase and not the acid. Notice that this is AQ. It has to be dissolved in water for it to be considered an acid. So oxyacids are the ones that come from polyatomic ions. Oxyacids are acids that contain oxyanions, found in the table of polyatomic ions. For instance, here's the hydrogen. Remove the hydrogen from the scenario, and we have NO3. NO3 is nitrate. If we move the hydrogen out of the scenario, we have SO3. SO3 is sulfite. There's going to be a really easy way to name these, but you have to know how to change the word. It only changes slightly. These acids are a combination of one or more hydrogen ions with an oxyanion. The number of hydrogen ions depends on the charge of the oxyanion. So, if we're looking at the polyatomic ion list down here, this has -2, so it's going to have 2 hydrogens. This has a -1, so it's going to have 1 hydrogen. So as we're naming these, the oxyanions ends in either "ite" or "ate." For instance, sulfite or sulfate. We're going to change this ending of the word. If it ends with an "ite," we're going to change that to "ous." If it ends in "ate," we're going to change that to "ic." So for instance, NO2 is originally nitrite. We change that to nitrous acid. We know by the name that it's not a binary molecule. It's not right off the periodic table because of the fact that there's no hydro in front of it. So even though if this was like this, it'd be HN, it'd be hydronitric acid, we would know that it's still not a polyatomic ion because of the part of the word that says hydro. Hydro means it's coming right off the periodic table, where here there is no hydro out here. It's just nitric acid. So the "ates" becomes "ic," the "ites" become "us." So break it down. SO3 is sulfite. ITE becomes OUS, so it becomes sulfurous acid. ClO3 is chlorate. The 8 becomes ic, so instead of chlorate is chloric acid. Alright, so let's try naming some of these. HCl. We have 2 capital letters here, which means it's right off the periodic table. So we have to figure out what Cl means. Cl is chlorine. So chlorine becomes chloric. Because it's right off the periodic table, we're going to put hydro in front of it. And then we're going to add the word acid at the end. HNO3, we have 3 capital letters. We have more than 2, meaning that we have a polyatomic ion here. NO3 is right here. It's nitrate. Because it ends in 8, it's going to change over to ic. So nitrate becomes nitric. Because it was a polyatomic ion, I do not add hydro to it. Let's try another one. SO4 is sulfate. It's right here. It ends in 8, so 8 becomes ic. So sulfate is sulfuric. Yes, I realize that when it added a little bit there, that's just something you're going to have to remember with sulfate. ClO3. ClO3 is right here. Chlorate. 8 becomes ic, so it becomes chloric acid. And finally, we have SO3, which is right here, sulfite. So of sulfite, that ite becomes OUS, sulfurous. Alright, let's try to reverse the process. Hydrobromic acid. Hydro means that it's coming right off the periodic table. So that means we have to look at that stem, the middle of the word. So bromic means bromine. Hydrogen. Now we have to, at this point you have to look at the periodic table. Bromine is right here about. It's in the -1 row. So that means it has a -1 charge. Hydrogen has a +1 charge. Crisscross it and it becomes HBr. Nitric. Ic came from 8. I notice that there's no hydro in front, so that means it's a polyatomic ion. So I'm looking for nitrate. Nitrate is right here. So it's NO3. I'm looking here and I see that it's a -1 charge. So if I were to crisscross that down, it would be 1 hydrogen. Sulfurous. OUS came from ite. Once again, there's no hydro in front, so I know it's a polyatomic ion. So sulfite is SO3. Notice here, it has a -2 charge. That means I'm going to have 2 hydrogens here to balance it out when I crisscross it down. There's no hydrogen, so that means it's a polyatomic ion. OUS came from ite. So sulfurite, or phosphite. I'm not seeing phosphate on the list. That's okay. It's PO3 with a -2 charge. So that means this 2 comes down to be H2PO3. And finally, we have acetic acid. Once again, no hydro. That means it's a polyatomic ion. The ic came from 8. So that means I need acetate, which is up here. C2H3O2. It's a -1 charge, so that means I need 1 hydrogen. Notice that there's actually 4 hydrogens here total. We're going to leave this hydrogen up on front because that's the one that's going to dissociate. That's the one that's going to break off when it gets into the water. Alright, so what we've done today in this tutorial, we were looking at acids. There's 2 different types of naming acids. There's the binary, which is 2 elements, the hydrogen and another element. Those you look on the periodic table and it starts with hydro, and it's the base of the other element with ic at the end. Oxyacids are polyatomic ions, and they have either ite or ate. If it ends in ite, you're going to change ite to OUS. If it ends in ate, you're going to change ATE to IC. And that's how you name acids.